Hello everyone, my name is Jim Garrity. This set of three videos is about a project I completed quite recently. It involves using my lathe and my milling machine and also my wife's sewing machine. I had to fabricate a shape out of segments of foam and then warning here, I also had to sew together a furry cover. Now don't worry, the girly bit is shown in the second video. You can skip that one if you're worried someone may see a sewing machine on your screen. Anyway, on with this video and a picture of a microphone. Microphones are sensitive instruments, designed of course to pick up sound and as much of that as possible. Their sensitivity becomes a problem when you take them outside and the wind is blowing. Moving air generates sound as it passes around or through the microphone. As the sound is being generated right by that sensitive microphone, it's picked up to the detriment of the sound that you want to receive. There is a simple solution that works quite well. You give that microphone a furry overcoat. It sounds too simple to be true, but it works. It lets the sound in but not the wind noise. This solution is used most of the time when recording sound out of doors. Here is the sound man. He's recording some dialogue from an invisible thespian. If you're lucky enough to be a sound man, you too can stand around like this all day, waiting for your arms to fall off. These furry overcoats for microphones, they seem to have a lot of names. Windshields, hairy hot dogs, windjammers, dead cat on a stick to name but a few. I think I'll stick with the name Windjammer. Now, why am I going on about windjammers? Well, I'd found a design requirement on a website that sounded interesting. Someone was developing an acoustic system for detecting and tracking airborne drones. They required a windjammer to cover their specialist microphone, but this windjammer needs to be a special shape. It had to be a truncated sphere, and as close to the correct shape as possible. Why a truncated sphere? Well, the windjammer's furry coat covers a layer of open cell foam. This combination of fur and foam prevents the wind producing any noise whilst being almost invisible to normal sound. But it will attenuate the incoming signal slightly. If the windjammer's shape is a sphere, no matter which angle the sound arrives from, it will pass through the same amount of thickness of windjammer wall, so have the same amount of attenuation. This is important when you're trying to track something that's a moving target. Well, I had a couple of ideas on how to create that spherical shape. So I sketched down my ideas, I wrote down some words and I sent it off to the people who required that specially shaped windjammer. Well, what do you know? They liked the ideas that I sent and they said, could I make them a prototype? Well, what do you know? I made a prototype. Let me bring you in closer and you can have a look at it. My basic idea was this. If you have a piece of spring steel and you held each end at the correct angle, it would form a circle. If you could do that multiple times around, say, a support ring, then all those circles would build up a sphere. And that's what this achieves. The aluminium support ring is 6.5mm aluminium plate. There are 3 sets of wires which go in this direction and then another 3 which goes in this direction. So you see there is a center wire and then 2 side wires, and then again 90 degrees around there's a center wire and 2 side wires. The center wire is slightly larger and longer than the 2 side wires. They are held in position within the ring by M3 grub screws that go through the side of the ring. Here is a section drawing of the dome cut right down the centre. This is the support ring. This is one of the centre wires, and this is the centre point of the sphere. The sphere needs to be 192mm in diameter, that's about 7.5 inches. Centre of the sphere is up 38mm, that's 1.5 inches from the lower face of the support ring. This drawing I made full size so I could measure the angle of the circle where it passes through the support ring just here. It was 67 degrees up from the horizontal. I made a second full-size sketch. This one shows the path of the side wires. I measured the angle of the circle of the side wires where it passed through the support ring just here. It was 65 degrees up from the horizontal. Well, I'm pleased with this prototype. I'm confident it conforms to the requirements laid down in the design specification, so I pack it up and head off to the customer for a design review. The customer is happy. I'm asked if I can produce a production batch of 20 units. I say yes. I'm also asked if I can produce a shaped foam dome to go over the wire frame and then the furry cover to go over the top of that. Well, I haven't worked with foam for years and never made a furry cover. I wonder for a while if I can do it. The little voice in my head says, "Of course you can." I have a small roll of 6mm thick medium density foam, easily enough to make a few foam domes for the windjammers. The customer has given me an offcut of furry fabric and I'm hoping enough to make a whole cover. I place orders for all the parts required to make the production batch of windjammers. I'm actually going to make 21, that'll give me a spare just in case. While I wait for the orders to arrive, I'm going to work on the shape of the pattern I need to cut the foam to so it takes the form of a dome. To cover a hemisphere in a flat material, you normally cut it into sections, say 6 sections or 6 segments around here. Then each of those segments needs to be a special shape, so when they stick together along their edges, it forms the dome. Well, this is my starting shape. Now, I found on the internet a calculator which calculates the arc that's shown here. The way they do it is by dividing this in segments, cutting it through, finding out what the diameter is at that point from the top, working out the circumference, dividing that circumference by the number of sections that you have or segments that you have, and that gives you the distance across here at that particular layer. You do that multiple times and it gives you a series of dots. You join the dots, that gives you the curve. Well, from a calculator I found on the internet, that gave me this shape. I cut 6 of those shapes out, which then gave me a cone. Now I stuck them all together to make my first hemisphere. Now it's looking a bit beaten because when I went to see the customer yesterday, he had a puppy and the puppy stomped on it. So I now need to play with it again because it sort of fits, but it's not brilliant. There's a bit of space at the top. Once I get a good fit in paper, that will give me the correct segment shape. Once I get the correct segment shape, I can then move across to the foam, cut the segments out in foam, glue them together along their edges, and that will give me a nice covering, I hope, of foam over the hemisphere. Let's see how it goes. I've been playing with that first dome that I made out of paper. Made some modifications to this, and I think I've got a better fit now. Proof is in the pudding. So the new profile I've now put onto paper. This is now template number 2. So hopefully when these come together, they will fit that hemisphere a little bit better. Now the way that I'm doing this, I've got a piece of wood which is cut to the same radius as the dome that I'm trying to cover. The 2 pieces of paper I put together so they're edges are just touching in the right place, and then on this piece of metal I put a run of masking tape down, cut it up into little bits with a scalpel, and then just pick the edge up, which means I've now got lots of little pieces of masking tape, so I can push it on there. That gets the first bit put together. I now push the 2 edges together further down. This paper starts to curve over straight away and stick it in place. I can now come down to the next piece just there, make sure that the edges are together, take a piece of masking tape, stick it on, and so on. We will have a look in a moment. This is dome number 2 and it's a better fit than the last time. A little bit of space up here, and at the bottom down here it's too big, so I need to reduce the width of the template at the bottom. Right, let's have a go at template number 3. These are templates number 3. They still didn't fit completely as I hoped, so what I did, I split each of them down the centre, pulled them to where I wanted them, and then put more sticky tape across the joins. And now we've got a fairly good fit all the way round the dome on the inside, which is excellent. So what I'm going to do now is cut the 3 sections or the 3 segments, put them one on top of the other, and then out of that get an average one which I'm going to cut straight into the foam, and I think that should fit on quite nicely. Now the foam has got to come right the way down to the ring here, so I'll be cutting them a little bit longer, but also tapering them off at the bottom, because the dome finishes here and it starts going underneath. The equator is sort of it's here where the paper finishes there, and then it starts going down, so it's tighter at the bottom. Cutting the segments for the first foam cover. Well, with all the segment cut, I needed to stick them all together. The adhesive I'm going to try first of all is this one here, Gorilla Contact Adhesive. Now I've been told this is a fairly good adhesive for foam. Now I cut the pieces out last night from the 3 segments that was formed around the dome, and started gluing them together. What I found is the contact adhesive, it says leave it for 2 minutes and then push the surfaces together. Well, I left it for 2 minutes, pushed the surfaces together, but then they started peeling apart again. What I found is, I think it's because the surface of the foam is absorbent, the adhesive goes into it and it can't dry properly, so the wetting agent of the glue stays in there, and then that allows it to pull apart. So what I did, I left it for 12 minutes. In fact, I left it for 5 minutes and then 10 minutes, and it seems 12 minutes seems to be the time. 12 minutes, then push them together really quite hard, and then I go over it again, and I've ended up with a bond like this. So I put the 2 segments together, and then I did another 2 segments and another 2 segments. So I have these 6 segments stuck together. Now I did this last night because it says on the tube it doesn't reach its full strength for 24 hours. I also did a test piece here to see what the adhesion of the joint was like, and you can see that it's actually really quite strong. And also, if I pull at the ends to try and tear the joint, it doesn't tear. Obviously, if I pull really hard, it will tear, but I have a feeling that the foam will break before the joint. So that's really good news. That you can actually feel the joint through here. There's a layer going all the way through, which is quite hard, and I'm hoping acoustically that's going to be all right. I don't know if that will cause a blind spot. It is in line with the microphone. I don't know if it's going to give it reflections, but we'll have to experiment with that and see how it turns out later. Anyway, job now is to glue these 3 larger segments together to see if it makes a nice dome. Right, we have all the adhesive on all the joints. You notice that I've put dots on here. That's because these are the first 2 surfaces I put the adhesive on, and then I started the timer. When I finished this, I finished the glue on these 2 surfaces first, started the timer, then I put the glue on these 2 surfaces where it's got the 2 dots, and noted down the time, and then I did the 3rd surface and noted down the time. So 12 minutes from its start time is when I should put these together, and it's now 13 minutes. So I need to now push these 2 together. So I line up the top, and I'm starting from the top of the cone each time. So push it together nice and hard, and you've obviously got to get it level. My next time is 15.5 minutes for joint number 2. Because it's trying to make a dome in this direction, the outside of the joint is the part that's under tension, and that's the part that's ripping away. Inside the dome, then that's where it's being pushed together, so you don't have problems inside. It's just the outside of the joint which starts to pull away. So it's had 12 minutes drying time before the surfaces are pushed together. The temperature at the moment is 18 degrees in the workshop, and it may be cooling down a bit because the door is open because of the fumes of the adhesive. Okay, 15.5, so we're ready for joint number 2, which are these 2 here. Joint number 2 is pushed together. I crimp along its edges with my fingers, and that ensures that the adhesive is well bonded. Next is joint number 3. I do the same procedure here as well. And we are done. One dome. Look at that. And it's not looking too bad. I did some basic measurements and it looks like it's going to fit the dome, which is going to be handy. The joints are all looking pretty good. There aren't any that are pulling apart. Got a little hole in the top which won't go together. What I think I'll do is stick a little bit of adhesive in there and then close that up. But it's looking good. I've just got to wait now for the glue to cure. I'm really interested to see if it's going to go over there and fit nicely. Looks about the same size, isn't it? So tempting just to give it a quick push. Oh, no, I can't do it. If it rips open, then I'll have to stick it all together again. Right, wait for it to cure now. When I glued the dome together this morning, I've got those last 3 segments all as one. I also stuck together a couple of pieces of foam as well to check how the joints were, or how the adhesive is drying, and that check is pretty solid. Look at that. So I'm convinced I don't have to leave it overnight. Now I did that at 8 AM and it's just after 10 now, so that's 2 hours, and that's given me enough confidence to try and to push this over the dome. These aren't coming apart, so I think let's give it a go. Ooh, look at that. It fits. It fits. We've got a little bit of clearance actually. Well, I've had a bit of a think. It's just dawned on me that when I cut the segments to make up the dome, I cut them a little bit long. So once the dome was finished, I could then cut them off to the right length. Well, I haven't cut them, so they are too long and they're holding the dome up. So the dome will come down nicely to those spring steel wires once it's cut to the right height. So what I've done, I've just marked a red line around the bottom here. I'm now going to cut the dome to that line, and hopefully this will then sit nicely against those spring steel wires. Let's give it a go. The foam cuts nicely. I'm taking off 10mm. That's about 3/8 of an inch. And what do you know? That was the problem. Whip a piece off the bottom, not that much really. Get it all nice and flat, and now the dome fits nicely on top of those spring steel wires. Look at that. A thing of beauty. That, not me. Well, look what's arrived. I have a bag, and it's full of, ta-da! Furry material. And the furry material is the material that's going to cover this dome. Right. All I've got to do now is work out how to do it. The construction of the furry fabric stretch covers will be shown in the next video. Anna had given me permission to use a sewing machine, but I didn't feel much at home there. Making furry covers turned out to be far more difficult than I thought it was going to be, but we did manage to do it in the end. And with that, this is the end of the video. Take care everyone. See you next time. Could you do something like this? Of course you can.